Yes, our dear viewers, you're most welcome once again. As as usual, I'm again here to take you through this that we are going to look at today. But before we continue, I want to tell people that you can go ahead to subscribe. Subscribe costs nothing. Then else, you can share, you can like. Alright, I will find something in the comment section in case you're interested in asking a question. If you can't use the comment section down there, please you can go ahead to send me a WhatsApp message, or else you can call me on 07588767. For more clarification, you can ask me, or you can write a question. You can take a photo and send via WhatsApp. Send me an email on dixokasa@gmail.com. I'll be able to receive you and I'll be able to correct you, or else I'll be able to respond to you immediately. Today we are still looking at complex numbers, but the complex numbers that you are the part of the complex number that we are interested in today is the algebra of complex numbers. So what do we mean by that? Let us first write the heading, algebra. We are looking at algebra of complex numbers. So when we look at algebra of complex numbers, I told you that we shall be looking, last time I left here and I told you that we shall be looking at addition, subtraction, multiplication, and division. So let us begin with addition. What do we do when it comes to addition? Let us assume that we have two complex numbers. Let Z1 and Z2 be two complex numbers such that Z1 equals X1 plus Y1I and Z2 equals X2 plus Y2I. We are having two complex numbers with Z1 equals X1 plus Y1I. Then the other one is Z2 equals X2 plus Y2I. Each and every complex number there has the imaginary part and the real part in that case. So we want to see when we are adding, what do you do in that case? And we want also to have a final conclusion we need, such that everyone knows. So we are saying that if you are adding sum, that is in Z1 plus Z2, what will it be? Our Z1 is X1 plus Y1I, then plus our Z2 is X2 plus Y2I. So what are we having? Z1, in this case we are having this one and this one. Here we collect like terms together. Add the real part to the real part, and also the imaginary part to the imaginary part. That's what we do. So this is the real part, and this is the real part. Plus imaginary part, then imaginary part also. So in this case, we are saying that Z1 plus Z2 equals X1 plus X2, then plus. When we look at this, Y1 plus Y2, you see that I is common. You can put it out. If I is common, you put it out. So in this case, when you look at our final answer there, what do you realize in this final answer here? You see that the real parts are together and also the imaginary parts are together. So which final conclusion do you make? Is that when you are summing two complex numbers, their resultant answer always become the sum of the individual parts. For example, the real part will be the sum of the individual real parts, and also the imaginary part of the resultant answer will become the sum of the individual imaginary parts of both complex numbers. That's what we do in that case. So when you look at this, X1 was the real part of Z1, then X2 was the real part of Z2. Y1 was the real part was the imaginary part of Z1, and Y2 was the imaginary part of Z2. That's what we look at. And when you sum up, that's what you are seeing in that case. So summation will always give us that answer in that case. Let us, before we look at a certain example, let us first look at subtraction and also see how what happens before we can generate a certain example. We are saying Subtraction of complex numbers. We shall use the same concept that let us assume that z1 and z2 are complex numbers, whereby z1 equals x1 plus y1i, and z2 equals x2 plus y2i. What happens in that case? If that's the case, we are saying that in case that's the case, subtractance z1 minus z2, you see what will happen? z1 minus z2 equals x1 plus y1i, then minus x2 plus y2i. So z1 minus z2 equals, opening these brackets, you say x1 plus y1i minus x2, multiply this minus y2i. Now when you reach there, you now you have to go for collecting leg terms together. Get the real part onto the real parts, the imaginary part onto the imaginary part. Okay, we are saying that subtract the real part minus the real part, and also imaginary part minus the imaginary part. Don't subtract real part minus what? Imaginary parts, no. So where are the real parts there? We have x1 and x2. The imaginary parts are y2i and also y1i. So let us see. This one, x1 minus x2 plus y1 minus y2, but I is common in that case. So when you look at that one, you can also see that the real parts and the imaginary part, the real part and the imaginary part of the resultant answer, or of the difference of the two complex numbers become what? They will always become the difference of the individual parts. For example, the real part of the difference will always be the difference of the real part of the resultant difference. Is always the difference of the two real parts of the two complex numbers. The imaginary part of the difference of the resultant difference is what? Is the difference of the two individual imaginary numbers. Or the imaginary part. So that's what we are looking at in that case. That's what we are looking at. So when you look at that one, subtraction is always that. So let us look at a certain example. Let us look at a certain question, so that we can see. Question. We are saying that it is evaluate. Given that z1 equals 1 plus 4i and z2 equals 2 minus I, find my number 1, z1 plus z2, my number 2, z1 minus z1 minus z. We want to see how we can apply that, you see? My number 1, which is z1 plus z2 solution. What do you mean? z1 plus z2. What is our z1? Our z1 is 1 plus 4i. Then plus our z2, 2 minus I. So when you reach here, this is 1 plus 4i, then plus 2 minus I. So what are we doing? We are saying that 1 I is the real, and we say that 1 plus 2. Then plus this plus that, 4 minus 1, I is common, put it outside, and we are saying that this is A, plus 4 minus 1, great I. So this one becomes the resultant answer. So the resultant answer, how are you getting it? You are getting it by, this is Z1, then this is Z2. Go on the real part, 1 plus 2, you get 3. So 4 minus 1, you get 3. That's how we are getting that case. By adding. Now, when we are subtracting it, my number 2, z1 minus z solution. Z1 minus z2 equals 1 plus 4i, that is z1, then minus 2 minus I. Open the brackets, 1 plus 4i, then minus 2 plus I. And when you reach here, this is 1 minus 2, then plus 4. Plus 1i. And we are saying that this is negative 1 plus, this is 5i. So this is z1 minus z2. So you can can still move like that. So just apply the real parts to real parts and also the imaginary part to imaginary parts and finalize with that. So I don't think this is hard. It is always something very easy. You can deal with it and you understand it. I want to wish you the best, but don't forget to subscribe, like and share. Send me a message, an email, or else you can call 0758876705, or else send me an email on dixokasan07@gmail.com. We shall meet in another day. Don't miss the next session. I want to say that the next session may be about multiplication and division. Today we have looked at addition and subtraction complex numbers. The other part always need you to listen by yourself, not someone tell you. So don't forget, don't miss multiplication and the division of complex numbers. I want to wish you the best at this particular moment.